right, hello everyone. My name is Timothy Lee Grant, and now we are going to continue our journey on trying to learn machine learning and trying to just explore this different topic. So far, we have been introduced to so many interesting topics, not only just in machine learning, which we're going through that, but also we've been introduced to so many like object-oriented programming concepts, and it's always interesting doing projects like this because you never know what you're going to run into. You go and you think that you're going to be doing one thing, and then you get completely confused on some topic, and you're like, "Man, what is going on here?" And then you investigate, and then all of a sudden you're like, "Oh, I see. Okay." And so let me recap kind of where we are, and then let's start moving forward. So let me minimize myself first. All right. I am going to close out all of these things right here. So this is kind of the world which we are living in. Okay, so there's a bunch of different files here. There's train.py, there's test.py, there's data, datasets.py. Then we have something in here called a folder called models, and then there's this Linnet.py. Okay, so those are our scripts. And then we also imported the actual data. So this is the MNEST data. It is a bunch of like pictures essentially, and people hand drew like a 1 or a 2 or something like this. And the idea is we're trying to predict those hand drawn numbers. We're trying to classify it. We're trying to say, like, okay, someone drew a 1. How does a computer know that that's a 1? That's kind of what we're trying to do. So this is computer vision. We're teaching the computer how to actually do that. Okay. So our train.py or train.sh shell script, right? We're passing in, we're doing Python 3. So these are the programs which we're going to run. So we're doing Python 3. So we're invoking Python, right? We're doing train.py, okay? And so this is train.py is kind of going to be our entry point. Now, then we are passing in, the only thing that changes between all of these are the model and the dataset. Model is the Linnet, and the dataset is the MNIST. Now, you see that there's a whole bunch of other ones here, like this different models and different datasets, okay? But we're just focused on this one right now, and the reason for that is because I don't know what's going on with all of these different I'm trying to figure out, like, okay, what is even happening in this train? How is it working? Is it right? How do we fix things if it's not right? And kind of uh going about troubleshooting things. So we come here, and when we evoke this train.py, we come here, and now we just tell it that it is the Linnet model. We're not actually uh, parsing the arguments which are passed in. Likewise, where's the other one? I, Here, the MNEST. So we're just giving it the MNEST data, and that can be found here, right? So we're not saying, like, okay, which argument did you give us? And then based off of that, we choose either get MNEST or the CFAR 10. No, no, no. We're just hard coding it right now. Later on in the future, we're going to be making some changes. We are going to be parsing that. But for right now, we're just sticking with the base case, I guess you can call it. And no, this is not coffee. If you notice the time, it is 12 a.m., so it's 12 midnight. Um, but I said that I was going to make a second video. So today, this is the third video in my exploration in machine learning. Um, and today, I've actually already made part two, right? And this will be part three. So I already made a video on this, but I'm just so interested in it. Every time I do this, I just get so excited, and I'm like, I love this. This is so fun. I really like this stuff. This I don't know, when I do stuff like this, like actual software engineering, I just get so happy, and it's so fun. Like, I like this. I don't know, embedded systems, I mean, I really like this kind of software engineering. I mean, embedded systems is cool because you get to do like robots, but I just have that spark for this kind of stuff. Just like it's interesting, you know? It's fun. It's fun. It's fun. So, anyways, yeah, so let's just start going, right? Like, so we get this, right? Okay. So where are we? We get the data, then we assign a model, and then we do the cross entropy. So we've already kind of looked through these in the other parts. Then we just choose this optimizer function, and it's a stochastic gradient descent. And here I looked this up. LR means learning rate. Okay, so learning rate of uh, 0.01. Okay, so then uh, we do train. Now train is up here, and we have this model.train, which this one gave me a lot of confusion. This is kind of what we were doing, not yesterday, but in the last video, so a few hours ago. So I was really curious, like, okay, well, this is an object right here, right? So this is like an instantiation of a class. How do you actually evoke it? And the way that it's done is because this Linnet, so if you notice, I have this Linnet here, and this Linnet inherits from this in module, and this in module has something which is like a dunder call. And this dunder call, it just it assumes that there is a forward function within the child class, and it calls that class, right? So what we're doing here is not there. What we're doing here, what's this guy doing? Let's close that. So what we're doing here is, ooh, where'd you go? Where'd you go? Here we are. Oh, sorry. This train, that was kind of dumb of me. I shouldn't have said that. That was wrong. This train just means we're setting a parameter within the model and we're saying that it's training. And so this train is part of the, I'm gonna close that. I'm going to close virtual environments. I don't need that. So anyways, that train is like a parameter, like a member variable within this in module. So we're just setting that. And so this kind of determines, like, are we training or are we testing? That's kind of how that goes. So now we're back here. So we set that. Now we're going through all of the epochs. Okay. Keep track of our loss. We set 0 grad. So this is also just kind of like a variable that keeps track of things. Okay. Then we do our model. Now this is what I was talking about with how do you evoke a object? This was the thing that really confused me a few hours ago. And the idea is that dunder call. So I'm calling this object and I'm passing in a parameter called images. Now images we looked at, let me just run this. So copy and paste. So let me run this and show you kind of what we get. Oh, right. So, as you guys can see, we're getting the shape. And now the reason for that is because over here I printed image shape. All right. And now we can kind of see what's going on. There's going to be a graph that kind of pops up, so don't get too scared. Like when, ah, it's going to come popping up. But let's direct our attention here and just keep in mind that there's going to be a graph popping up. So again, don't get too frightened. Oh, there we go. There it is. Did it get you? Did you did it scare you? All right. So anyways, we ran this and we have our training loss over the epochs, and As I mentioned in the last video, I'm slightly suspicious about this because Susie is also, we're doing the project separately. So I'm doing the project by myself, she's doing the project by herself, but it's really nice to be able to have someone that you can kind of talk to and say like, hey, I ran into this problem. Are you running into it? How's this going? What's happening here, right? Communication back and forth. Also, it's just nice to kind of be able to have a project in common with someone. Me and her, we took a lot of classes together when we were doing university. Although I am electrical, right? I really enjoyed my CS classes, so in my senior year, I tried to focus a lot more on the computer science side of things. So, luckily, my school allowed me to take a lot of electives that were pure CS. So, me and her were actually able to take a lot of classes together, and then it's really helpful to have someone that you can even just discuss the ideas because what I realized is how powerful that actually was is to be able to talk to someone and you very quickly find out like, ooh, maybe I don't quite understand this topic as much as I thought I did because you're not able to actually articulate it. If it's in your head, you think you understand it until you try to articulate it. And then you're like, oh, I didn't understand it. I'm so confused. And then you're able to kind of start that conversation and then fill in each other's gaps, and it's really nice. But, anyways, where I was going with this is she had a problem that in her project, the training loss is actually pretty good. The training loss looks very similar to this. Now, the testing loss function looks something like this, which is not what you want to see. You want to see your training and testing kind of following each other. Maybe the testing is a little bit off, right? And that indicates you're slightly overfitting, but you don't want it to go up. That is not what you want to see, right? So I have a sneaking suspicion that there's going to be something wrong here. Now, she actually fixed it already. I don't know exactly what she did, but you know, we're I'm gonna try to fix it myself, and then we're we're just exploring here. This is just a fun time, right? Like I got off work. I don't need to be stressed about this. I just want to enjoy myself, build something, explore. Like have a good time. This is awesome, right? Like I don't know. I need to start seeing all of the positive stuff in life, not be too stressed out. Because, like, I don't know. At work, I'm learning a lot. Like, I'm learning so much. I can't even describe how much I'm learning at work. Like, I'm doing embedded systems. I'm doing electrical engineering. I'm doing, like, circuit analysis and, uh, like trying to diagnose communication, the physical layer of communication protocols using like taking an oscilloscope and putting it on those wires that are transmitting the communication between a microcontroller and an external uh, device, right? And I'm watching the signals go high and low and then going and trying to determine like is this correct according to the communication protocol and like so I'm learning so much. I learning so much at work, and then my projects are also like I don't know, it's fun. It's fun. So, but I don't want to be like I'm gonna do I have to do it. No. Just like chill, you know? If there's a problem on the horizon, okay, that's fine. We'll deal with it when we get there. Okay, I don't know if I'll be able to keep that attitude. Sometimes when you're in the heat of the moment, you just get like riled up and you feel like you're like in a fight for your life against this foe, which is like not not even there, right? It's like this I don't know who it is or what it is, right? But you're I will win, I will win. And you get just so emotional. I can't do it. All right, like what is going on? Man, come on. What's this problem? Another problem? Oh no. Well, maybe I'm stupid. Maybe I'm dumb. I can't do it, man. And then, you know, next day, you get out of bed and you're like, "Oh, okay. Well, I feel better now. Let's try it again." That's normally how it goes. It's like I'll be going at it, going at it, going at it, and then I'm like, I can't get it, and I'll be struggling with one thing, and then you wake up the next morning and you're in a much better mood, and then you get on it, your project, and you're like, oh, that's okay, I got it, or something like that, right? Like, anyways, I completely forgot what I was even talking about. Something about loss function. Oh, right. There's a problem on the horizon. We'll deal with it later. Okay. It's fine. So, all right. Anyways, I was going to show you this. Okay. So, which is corresponding to this right here. Okay, so we have this is 64 images, right? So there's 64 by 1 by 28 by 28. So we have 64 images, so we're able to index what image we want. And then each image has 28 pixels by 28 pixels. And so for each pixel, there is going to be a grayscale value, 0 to 1, right here. Okay, so you can index whichever pixel you're looking at and whichever photo you want. So photo 5, pixel 22 in the X direction and 3 in the Y direction. What's the grayscale? Okay, and you have 64 images, and so that's kind of what this is we just have a whole bunch of images, and that's called the batch size. Alright, so we pass that into this model, and now model is that dunder, right? Because this is an object, you see. So this is just an object, and this inherits from this in module, and this in module has something which is the dunder call, and this dunder call will evoke this forward method and pass in the parameter which you passed in as x. Okay, so this is kind of where we were leaving off the last video is, okay, cool. We have something called forward. We're passing in this x, which is the 64 images and the associated values with them. Okay. Again, this is not coffee. This is water. I have a very bad habit of drinking coffee at midnight, especially when I'm making videos, because I just need to give myself kind of that mental edge. But I mean, this video right here, as you can probably tell, is kind of just like a low key, a chill session, having fun, vibing. All right, we're gonna have a good time, So, yeah, no coffee needed today. Just enjoying ourselves, Don't need to be hardcore. Okay. So, anyways, what are we doing? So, notice that we're passing in this x, and then we're capturing the x here. So we're transforming the x. We're doing something here, and then we're doing something here. So we're passing in this x as a parameter to this conv1, which I don't know what that is. Okay, well, it's right here, but I don't really know what's going on there. But anyways, then we pass that through this as a parameter, and then we capture it here. Okay, so I do know ReLU is like an activation function. So I know that it has machine learning when you are trying to do a gradient, okay, I know that you need to have a nonlinear function. And I also know that if you have an actual like kind of parabola, the derivative is always changing, right? So what ReLU I believe is, and I can verify this, but I think it is kind of like this. It is piecewise, so it's straight. It's 0 all the way from negative infinity to 0, and then at 0 it has, so it's 0 and it has a slope of 0. Then at 0, x equals 0, then it starts going up and it has a slope of 1. And so it is nonlinear. It is nonlinear, but it is piecewise linear, which makes it really nice and easy to do a derivative on. Okay, so I think that's kind of what's going on right there, right? So the derivative at, let's say at negative infinity to 0, that derivative is going to be 0 because the slope is 0. The derivative at anything x is greater than 0 all the way to infinity, positive infinity, is going to be 1. The derivative is just 1 because the slope is 1. Okay. So let me, before I go and talk too much, let me make sure that that's correct. ReLU function. It should be, yeah, there it is. Okay, let's, yeah, there we go. At 0, you see at 0 right here. This one's easier to see. At 0, so it stays at 0, and then all of a sudden goes up and has a slope of 1. And it's nice and easy to take the derivative of that. So, let's see what is going on. All right. So, I have this here. Okay. And so I have this like batch, which is the 64 images and all of the associated values, and then I put it through this self.conv1. Now, self.conv1 is this neural network, so NN, and then dot conv 2D, and then 165. Now, I remember in, I think it was the first video that I made, I observed, look at this here, okay? So we have a 1 here, okay? Now 6, 6. Interesting. 16, 16, but times 4 times 4. I don't really know. I don't understand what's going on there, but I think that there's some connection. 16, 16, okay? 120, 120. 84, 84. Okay, so what is this kind of like ding in my head about? I think that this right here is the input layer, and this is the output layer. Okay, so we have one input into a node, and then that node has 6 outputs. And then we're just going to be connecting like this output to this one's input. Okay, and then this has 16, so each node has 16 that come out, and then we just pass it here into the input here, and then 120, same thing, right? And then look at this, 10. It has an output of 10. What does that seem like? Remember, what were we trying to do? We were trying to classify handwritten numbers. 1, 5, 7, 8, 0, right? We're trying to classify 0 through 9. There's 10 of them. So, what I'm guessing, what I am guessing is that this 10 here is the probability, it's going to be the probability of its respective number. So, for example, if we have a photo, right? We we have a photo and each ooh, I didn't mean to do that. We have a photo and we want a vector of 10 values. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? There's 10 indices, 0 through 9, and each indice is going to be filled with a probability. That probability will correspond to the probability that that picture is that number, right? So let's say we have like a 0.9 in the category 7 or index 7. So what that would correspond to is that there's a 90% chance that this photo is the number 7. And then obviously this has to conform to the rules of probability. So you add up all of the probabilities, you need to get to 1. Okay? And we don't need to worry about the other ideas of probability of, what was it? It was like, let's see, the integral from negative infinity to positive infinity of the probability distribution function is going to be equal to 1. What was it? The cumulative distribution function, it starts at 0, it goes to 1, and never goes above 1, and never is decreasing, right? So anyways, we don't need to be worrying about that. That was, what class was that? Probabilistic random signals, I think it was. That's what ours was called, but I think other people took just like, it was called something different, but it was the exact same topics. But anyways, it was a fun class. I liked it. I like math. Math is really nice. When I was in high school, I hated math because I just wasn't. I felt like I wasn't good at it. But then I don't know what changed. I mean, I think that there was a lot that changed. Let's see. My study habits changed. So before, I was working very hard to try to understand math. I was putting in a lot of time, a lot of effort, but I wasn't doing it efficiently. I didn't know how to actually systematically learn the mathematics, and I would be trying to learn calculus. But actually, I was missing fundamental things in my algebra. And so when I real so okay, I remember a story. Okay, there was I was in I was working in this company that does essentially I don't want to say, how do I describe it? I was in production, but I was kind of like fixing robots kind of thing. That was kind of my job, right? It was that was a fun company because it was very much just like it was you could just show up. I just show up, like you could show up anytime. No, that's not what I mean. Obviously, you had your set schedules, but I mean, I liked it because I just went into work and I would just like feel really productive. I would be having all of the robots running really smoothly, and whenever one would go down, I would be able to go and try to fix it, figure out what was wrong with it. Anyways, I really like that job. But the company obviously has a lot of engineers, and I got this job the month that I turned 18. And so I got the job when I was really young, and then I stayed at the company for like 8 years, something like that, while I was going to school. So I was going to school part time, and then uh, at a community college at first, and then I went, I work full time, right? So, where was I going with this? I was doing really bad at math. I was at my university or college, community college, and I was doing, I think it was Calc 2, which was integral calculus, or either Calc 1 or Calc 2. And it was Calc 1, 2, integral calculus, yeah. And I just barely passed Calc 1, and then I was in Calc 2, and I was doing really badly. Like, really bad. I couldn't understand it. And there was this older engineer. He was maybe 60 at the time, 60, 70, something like that. And he had a very, like, his demeanor was very Soviet. Okay. And by the way, he was from Moscow. So he was from the Soviet Union, right? And the timeline matches up as well. So, anyways, that company had a lot of Russian people, and they described him as KGB. Like, they said, "Oh my goodness, this guy, he is very kind. Like, he's a really good guy, but his character just reminds them of how serious the KGB would be." Anyways, so I told him that I was having difficulty in math, and he said, "No, team. No, you are not having a problem with mathematics. No, you are having a specific problem. You need to find this problem and kill it." And what he meant by this was, I said I was having problems with math, or I was having problems with calculus. That's no. What he was telling me is I need to find out exactly what am I having a problem with. And so I said, okay, I'll try it, right? Like, then when I went into math class, right? And I was doing my homework, I would go and I was trying to do my homework and I ran into a problem. And then I started writing it out and saying, like, uh what is the actual topic which I'm learning, whatever it was. Like, the I forget what the actual topic was, but I just said, like, what am I actually trying to learn here? And I described the topic, and then, okay, well, how does it work? How does this, I was it trig substitution or U substitution? It probably was U substitution. But anyway, so I would write out, like, U substitution. What is even the idea? And then I would try to, like, be very specific, and I realized, like, oh, I don't even know ac- like, really what this topic in differential calculus, Calc 1, was. And so then I would go online and look up that topic and then try to dig into that. And then I realized, man, I don't know what uh, this further topic is in algebra. Oh, man. And I remember looking at, I went down and I ended up getting into, like, this, like, high school math class. And I remember watching the video and I was thinking, like, my goodness, I felt really embarrassed about it. I was like, oh my gosh, I'm in college and I'm watching this video, and the introduction was like, learning is fun, something like this. And I was like, oh my gosh, it was like a huge blow to my ego. But, I learned it. And then once I was able to, okay, now I feel confident in this topic. And then I went back up to the Calc 1. And then all of a sudden I could understand the Calc 1 concept a lot better. And I was able to write everything out and understand, like, okay, well, here's this. And then from that, I was able to pop back up, almost like recur. Ooh. That's how you know you've done too much LeetCode, is when when recursion is the first thing you think of when you're talking about this. But anyways, it kind of like recursion, you keep popping back up the stack. So then I get up to the Calc 2 concepts, and all of a sudden I can start to understand it a lot better. And so this engineer, he was so correct about the idea that you have to narrow down, like drill down, find what your holes in your knowledge are, and try to fill those out. So I'm so thankful to him. Like he was such a, like literally that phrase, that one comment that he made impacted my life so much. The other thing that I think really impacted my mathematics, going from being horrible at it in high school and beginning of college to now that I really like math, is I had my Calc 3 teacher, okay? And she was talking, and at the beginning of the class, she said, by the way, if you're struggling, don't try to think of this as a mark against you. Don't think like, oh, I'm stupid about because I'm struggling. Struggling means that you're learning. If you're not struggling, you're not learning. The struggle is good. The struggle enforces it in your head. Now, don't struggle indefinitely. If you're wrestling with it for a long time, okay, come to office hours or talk to me after class and let's discuss this problem. But don't be scared of the fact that you are struggling. And previously I kind of had this idea in my head that I didn't even want to allow myself to struggle because it meant that I was dumb, or it meant that I wasn't good at it, and so therefore why am I doing it, or something like this. Like, it's hopeless. I'm not going to be able to get it because I'm struggling with it, right? But after she said that, I thought, like, huh, okay. And I kind of gave myself permission to struggle. And my goodness, that's such a true statement what she said about struggling means you're learning. And once I gave myself permission to struggle, all of a sudden whenever I was struggling with math, I'm like, "Oh, no. It's not because I'm bad at math. It's because I'm learning." And so this is something that really impacted my life. Now, obviously, as you guys see in my LeetCoding videos, I mean, obviously, I get emotional when I'm doing LeetCode and I just can't solve it, right? Like, I'm not this stoic where I'm just, oh, everything is okay. I'm never emotional about anything. Um, Obviously, whenever I'm struggling, I feel like, man, I'm so dumb. I can't solve it. I can't solve it. But guess what? I don't give up, right? Like that, and that's kind of the other thing that I'm trying to show with my videos is just like perseverance, just like pushing through things, moving forward, moving forward, moving forward, never giving up, never giving up. Even struggling is okay. Like that's the thing. Like a lot of people can look at my videos and say like, okay, this guy has no idea what he's talking about. He's a horrible programmer. He doesn't know anything about object oriented programming. Can you believe that this guy doesn't know this? Oh, this guy, he's terrible at LeetCode. Oh, this guy, he right. Like if you watch my videos, you know I'm not good at software engineering. I'm just not great at it, you know. But I'm learning, right? Like if you watch my videos, it's very easy to kind of like, oh, criticize, like, oh, he doesn't know this or he doesn't know that. And the reason that I kind of want to put it out there is like, yeah, I don't know it right now, but I will, you know? Right? Like 2 days ago, I didn't know really how to work with inheritance. Now I do. Okay, cool. awesome. You know, like struggling is okay. Just don't give up, you know? Even I think getting disheartened is okay. Like it's a natural feeling for you just to feel like, oh, I hate. And again, like that's another reason why I post those videos is like I get those emotions all the time. That's a natural emotion. Just push through though. Like, okay, feeling terrible. Wake up in the next morning. Well, still have to do it, right? Like there's things to be done, and that's why like I'm trying to I still have to do my leak coding video today. I haven't done a leak coding video. It is 12 okay, so I think I need to kind of investigate this a little bit more. So we're gonna keep going a little bit, but I'll try to wrap it up a little bit because I know that I need to do. I promised, like I am not going to miss a day. I'm going to do one leak coding video every single day, not like miss that. Unless, I mean, yeah. So the other thing is like, because I was just thinking about what I just said, and I was thinking, I was about to say, like, unless plans change, right? Like, I'm not, I said that I'm going to do a leak coding video every single day, but I mean, my plans could change, right? Like, I could be like, oh, something came up, or, and then trying to think, like, okay, well, maybe like generalizing it, like, what is the acceptable criteria? And okay, but then that's easy to kind of like say, oh, well, I'm just not feeling it today, and then not doing it. You know, there's, yeah, so that's why I was kind of hesitant to say that. Like, on one hand, I do want to say, like, oh, if your plans change, okay, don't do something just because you said that you were going to do it, or don't stick to a goal just because you said your goal 10 years ago, right? Like goals can change, motives can change, whatever you're trying to do can change, you know. But also don't just give up and just try to be consistent, you know. So anyways, it's more like philosophy right now. Um what are we doing? So, this guy here, let's go to that definition. Hey, we're back to our I think I closed this at the beginning of this video. So we have this, and so we're doing the initialization, and it has a whole bunch of, okay, like biases, whatever device is getting trained on, and then it returns none. It returns none, and then it does all of this, right? Okay. And then what does it inherit from? This convolutional ND. Okay. So it's inheriting stuff. Convolutional forward. Okay. So I'm guessing that I'm just doing a convolution, like passing it through a convolutional neural network, which is, let's I can just do this. I can ask Copilot, like, here, and then say, what do the parameters mean? Kind of like this. Oh, and the older like Russian guy, um, another thing that he told me was, uh, when I was preparing to go to Russia, he said, Tim, come here, come here. When you're in Russia, maybe don't smile so much. And I thought he was joking, right? And then I got to Russia, St. Petersburg specifically. Um, I got to St. Petersburg and I realized he wasn't joking. Like, the people there are very, I, how would I describe Russians? Like, I don't know, honorable. That's at least the way that I viewed it. Like, Russians are very honorable and very, like, they follow the rules and they're very, like, I don't know. I felt very like safe in Russia, and it was really nice. But they don't smile a lot, so they're very kind of like this. When they talk, they'll talk like this. And when you go to the store and you buy something, would you like a bag with that? Okay. Your total is this. Goodbye. Kind of like that. Like, and my ear, when I was in Russia, it just got trained for like certain words, like, sa blah 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 paketoja, and then I knew like, okay, that means do you want a bag? And so then I would say like, uh, because they charged for bags, so I would say, нет, пожалуйста, or yeah, нет, пожалуйста, and then there's a хорошо, which means okay. And then they would say the number. I would never know what the number actually was, but I would look at the little screen and just give them the rubles. I remember one time I made this cashier kind of upset at me because they told me the number and then I looked at the screen and then gave a much larger bill, and they love you to give exact change. And then she said something to me like, "Niet, blah 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 blah," and I just look at her, and I looked. I didn't know what she said. I thought maybe she was telling me that it wasn't enough. Like I gave her, I think it was like 5,000 rubles, and I look at the thing, and it was like I don't know how many 1,000 ruble. But I was like, okay. So I pull out another like 5,000 ruble thing and give it to her. Her face was and pushed the second 5,000 rubles, went to our cash register, got the money out, did the exact change, and then gave it to me. But I remember anyways, fun times. It was a fun experience. Um, where was I? What was I doing? So, um, oh, and the other thing, like when I was in Russia, they at that time it was during the elections and of the 2016 elections, and so they were very much like they really liked America, and every time that they would say, uh, I would say to them, "Yeah, Amerikansky," which means I'm American. They would say, "Hey, Amerikansky, yeah, yeah," like this. It was a fun time. It was um. So what's happening here? 165. Okay, so in channels here, one means the input has one channel. For MNEST images, which are grayscale, this makes sense. Okay. The number of output channels, also known as the number of filters or kernels. So I was right. Input, output. Okay, so here 6 indicates that the convolutional layer will produce 6 different features, or 6 different feature maps. These 6 separate filter kernels that will each convolve over the input image and produce their own feature map, okay? Probably need to kind of like look into this, like what does this mean? Kernel size, the size of the convolving kernel. Okay, so I mean, it's just doing a convolution. Okay, so then I pass it to the activation function, and then this activation function gives me some output. Then I put it in this max pool. And then let's see. Let's just normally if I do this, it kind of gets the context and will explain it. I don't even need to write like, can you explain it? Yeah, see. The line here performs max pooling operation on the input tensor X. Yep. Using a 2x2 kernel. So I don't know what that means. I don't know what pooling is. But it's doing pooling. So max pooling is a downsampling operation that reduces the spatial dimensions, height and width of the input while retaining the most important features. It does this by taking the maximum value of each non-overlapping subregion. Okay, a lot of machine learning stuff going on right there. We'll probably have to investigate that later. I'm just trying to get the structure of the code first. Okay, so it's doing pooling, and then we're doing a second convolution, and then a second pooling, and then x.view. Okay. Let's see what x.view is. Okay, view is a PyTorch method that reshapes a tensor. It returns a new tensor with the same data but different shape. Does not modify the original tensor. This is a placeholder that tells PyTorch to automatically infer this dimension based on the other dimensions. Okay, so it's just infer it. Okay, whatever. This specifies the new shape for the other dimension. Here it is a product of dimensions resulting in... Okay, sure. So I'm trying to get f.relu. Okay. Oh, and I'm passing it in here. So I'm changing the shape to be 16 times 4 times 4. So I'm changing the shape before I put it into the input layer here for this FC1. Okay, that makes sense. And then I'm doing the ReLU. And then I do the exact same thing for this FC2. So that's how we get 16 all the way to 16 times 4 times 4. Okay. And then we do it for F3. Our output is 10. So now X is 10. It's a list of 10 corresponding to the probabilities, presumably. So that's kind of how we do train. Wait, no, that's not train. That is here. Okay, so then we get output, which is, I'm guessing it's going to be that 64 by 10. Oh, yes it is. Right there. Right there. Right there. Look at that. 64 by 10. So 64, each 64 image, which was in the batch, and each of those has a 10-dimensional, or a 10 list of 10, right? Corresponding to the probability that that image is that specific number. So there's 64 times 10. It's a two-dimensional array, essentially. And each of the 64 images has 10 values that it could be and has its associated probabilities. Okay, so then loss is, I'm guessing that this is kind of, let's see, loss function, criterion. Pretty soon I'll probably have to start doing my leak. Oh, it's almost 1 a.m. Oh, I really need to get going. I need to do my leak code. Okay, but anyways, so criterion is passed in here, here. So cross entropy. So this is we'll look at the loss function in the next video. So we kind of understand how we get our outputs, and then we'll figure out how we do this and back propagation. I think this one is right here. So I think this one is like adjusting the parameters maybe, such that they align better with whatever our loss function said. Um, so anyways, thank you guys so much for watching this video. I hope you guys enjoyed it. And I will be making another video tomorrow doing more machine learning. So machine learning and LeetCode. So anyways, thank you for watching this video. I hope you have a wonderful rest of the day. My name is Timothy Lee Grant, and I will see you, well, I guess in like 3 minutes, because I'm going to be doing a LeetCoding video. But then I'll see you tomorrow.